how we can, the demo is going to show us how we can maximize some of these things that I am going to show you. For this event is also already streaming on YouTube. It should, YouTube will come live in the next 1 or 2 minutes. Again, we apologize for starting a little behind schedule. We're waiting for people to come on board. And of course, knowing that it's a virtual model, we didn't want to start and be talking to nobody. So we try to ensure that people are coming in. Somebody is asking for transcription. I'm not sure how that will work. YouTube will be online in the next. If I see, again, if the transcription, apologize for starting a little behind schedule. We're waiting for people to come on board, and of course, knowing that so we're live on YouTube, I can guarantee. We didn't want to start and be talking journey, so start trying to enjoy it now. So I am Tosin Shokukola. I am the convener of Analytics Africa. And Analytics Africa was set up to be a kind of melting pot for practitioners of analytics, especially in Africa. Can you still hear? Yes, I know what that's happening. I'm going to stop YouTube now. The audio should stop replicating itself now. So for practitioners in Africa, we tried to have a kind of melting pot whereby people who practice analytics in Africa can come together in one room and access a lot of benefits. That is benefits in terms of training, benefits in terms of networking, benefits in terms of know-how, and benefits in terms of job opportunities, benefits in terms of skill sharing, and so on and so forth. That said, we also have noticed that a lot of people have come to us to say, hey, Tosin, I'm interested in data. I want to do a lot of stuff. However, it is difficult for me to even know what to do. Some people are inundated by the big words: data science, machine learning, big data, business analytics, TensorFlow, and all those wonderful terms that we have. And unfortunately, the world is not making it easier when you are sharing information with people, when you are communicating with people. Sometimes you want to make whatever you are doing look complicated and look like a lot of hard work. So you now use a lot of big terms. You use a lot of big terms to ensure that it looks complex. So we've begun to see simple software solutions being referred to as artificial intelligence, machine learning. It was a work of, make people make it like it's rocket science. So one of the things we are trying to do with this meeting tonight is to put this there for everybody so that we can easily see and say that, see, you don't have to have an IQ of 150. You don't need to be a rocket scientist. You don't need to be Einstein's cousin. You don't need to be a genius. Anybody can do analytics, and we are going to run you through. I'll bring your indulgence. The demos we're going to run will go a little bit long. They are not going to be a short 3-minute demo. They will run for at least 15 to 30 minutes because it's a whole process. We are taking raw data. We are going to pump it into a NoSQL data store, and then we will start building a dashboard from there. Yes, thank you. So I'm going to start with the presentation now. I'm going to start with the presentation now, and I will at some point I will ask for questions and inquiries while we also continue learning. Now, this is a full learning process. We would want to share this document at the end of the day so people can be able to take advantage and benefit of it. Thank you. Someone has requested that I transcribe now because, can you hear me, please? Can you hear me, please? Can you hear me, please? If you can hear me, can I just hear yes and okay A thumbs up,
Yes.
or you can just say, okay, thank
Yes,
you.
I can.
All right, so we're going to start the presentation now, and let's see how quickly we can go. So what is analytics? Wikipedia says that analytics is a systematic computational analysis of data or statistics. This is a very, very, very long definition. It's long, it's complex, and it's very heavy. And of course, it comes to say things around it is also valuable in areas rich with reported information. In short, it's just saying analytics is the process of taking data using computers or a mathematical method of statistics and allows it to interpret data, discover patterns in data, and then when you apply these patterns of analysis, it will be able to get results for you. So in computer science classes, they tell us that raw data, we have two types of data. We have raw data and we have cultured data, which has been cultivated and massaged well enough to become information. The newscasters will differ with that and everything. But in computer science, what they teach us is that data is raw facts sitting down there without any meaning. And then when you now put sense to it, put meaning to it, it becomes information. So this is Wikipedia's definition. We have some more simple definitions, which is analytics is a systematic computational analysis of data. I don't like that first definition, it's complicated. The second definition comes to tell us that it is information resulting from systematic analysis of data. That is, you have a system, you have a repeatable method. When you talk of a system, when you talk of science, it means that the method is repeatable. And then we use that method to get insight from raw facts or raw data. And of course, it helps us to deliver content in different ways. Google also gives us its own information, its own perspective, which is the same with that of Bing, because they are both using Oxford Dictionary. But I still left it there deliberately because the pronunciation is different. I'm not sure whether it is British or American. So analytics is what Bing says, and then Google says it's analytics. Well, that's that. Okay. Now, another practitioner in data management called SAS says that analytics uses data and math. So if you go back to the previous one, somebody says systematic analysis or computational analysis. This computational analysis that we're referring to here is not using a computer or PC. When we talk of computational analysis here, this is talking of maths, where you are using digits and numbers to do whatever you want to do. So it uses maths and data to answer business questions and also to discover relationships and also to predict outcomes and automate decisions. It helps us to find patterns, and it also helps us to do statistical work around predictive modeling, machine learning techniques. Okay? Of what use is analytics to us? It helps us in decision making. It helps in customer engagement. It helps in influencing behavior. It helps us see insights and meaningful data that we might not otherwise detect. And this is not far-fetched. I remember reading a book titled The Smart Money Tribe or Smart Money Woman. And the woman there, the story is about a Lagos girl who is heavy at spending money. And she had a good job, she had a car, she had everything, but she was always broke. And she was always having to beg for money, or she was always having to borrow money, or she was always having to go for a loan. And then she had to learn a hard lesson, and then it really hit her so hard that she now sat down, took her financial statements, and started looking at where all her money was going. Like, I earn 500K every month, and I'm always broke. What's going on? Is anybody stealing the money or whatever? And then she now began to see, oh, I buy this, I buy that, I invest in this, I engage in this, I indulge in this. And this, at the end of the day, I spent 209,000 naira on clothes that I don't need. I am an impulse buyer. I am this. Now, that is a simple example of data. She has just sat down and she has gone to see a trend. In English, they tell us that if you do the same thing and you expect a different result, it is not wisdom. So that means a simple trend is you will have a particular behavior. You are sitting at 12 midnight and you are expected to wake up at 5 every time. And you are not changing that pattern of sleeping late and you're expecting to wake up early. It's not wisdom. But by the time you now begin to say, okay, maybe when I sleep early or maybe when I take something before I sleep better and I wake up stronger and more refreshed. That's a trend. Those are simple patterns. Now, begin to translate this kind of insight into how banks make decisions, begin to translate this insight into how countries decide on what to do, begin to make these translations into how a family builds their budget or how the World Bank or IMF begins to plan loans for the whole world. Today, Ukraine is fighting a war. America is promising billions of naira. You're not going to hear that America got broke tomorrow because they gave Ukraine $1 billion of weapons, or they contributed $1 billion to the war. No, they have done some analysis behind. They have looked at some trends. They have looked at some projections. And those projections have been able to give them insight into saying, okay, these are the things that we can do. This is how much we can afford. So analytics helps us to see insights, and it also generates meaningful data that we might not otherwise detect. It focuses on using insights from data to make more informed decisions that allow us to make increased sales or reduce costs or make other business improvements. Many of us work in companies. Like in my former company, every time it was your birthday, you get a cake. And then at some point they said, okay, we're not giving everybody cake again because the number of staff started increasing. They now said, at the end of every month, everybody will celebrate their birthday and you get one cake. Somebody had seen what? That, okay, the price of cake is almost reaching a particular amount. If we continue doing this every year, it's become a particular amount. I really don't support that. But again, that is strength. Now, somebody says, reduce costs. I've seen a company where when you resume, you get a car. But the financial advisor comes in and says, no, you should not give them a car because that car is amortized over 4 years. So why don't you pay them the money for that car over 48 months? Break that amount that they get in 1 year, break it down into 48 and you pay them monthly. Now, they have reduced costs because instead of paying you 5M for a car or 2M for a car at once, they have broken 5M into 48, which makes it as little as 120K per month or something of the sort. And then that money is going to be spread over 4 years. So you can imagine how much money they are going to save. So these are the kind of things that people do by just sitting down and looking at data, and then they are able to make decisions or make improvements or make budget costs or things like that. We can even bring it to your house. You see that in your house, you are spending too much on drinks or spending too much on some grocery or something that is not necessary. Then you say, okay, going forward, we're no more buying this kind of thing. We will start buying that kind of thing. Or because this kind of thing helps us do stuff better, we will invest more in it. Or this kind of training, when I did this training or this certification, I got a job, so I'll invest more. So it happens in our personal lives, it happens in business. Okay, so we move. What are the everyday applications of analytics? Like I said, customer behavior, business decision making. In Africa, we don't seem to use data, but we use data. You cannot have a national GDP if you don't use data. You cannot have a national budget if you don't use data. Are we using the data appropriately or 100% in the way that we should be using it? No. But are we using data at all? Yes. Because you cannot have any planning. Today, we complain that, oh, the Northerners vote a lot, the Southerners in Nigeria don't vote a lot. Come on, that is data. Whether they counted humans, whether they did not count humans, one way or the other, there is a counting, there is a result. Whether elections are rigged, whether elections are forged, what are they tampering with? It all boils down to what? Data. Because at the end of the day, they still need to come back and say, this person won by this amount of votes, and this person that did not win got this amount of votes. Now, the person who is rigging an election, because we're an election mode in Nigeria, where most of us come from, the person who is rigging an election has a lot of work, data manipulation to do. They will not just manufacture the data and say, oh, he won by 18 million votes and the other person got 12 million votes. No, it is a cautious data manipulation from the state or even from the ward to the state to the geopolitical zone, and then an aggregation of 36 states and federal capital territory, 37 constituencies as it were, to now give you a grand total result that makes it look larger than the opposing party or opposing parties, as the case may be. So in Africa, though we don't use data as well as we should use it, one way or the other, we are still using data, and it still helps us get stuff done one way or the other. Now, what kind of analytics do we have? We've said data, we've said prediction, we've said cost cutting, we've said budget improvement, we've said anything, everything. What kind of data or what kind of analytics do we have? We have the descriptive analytics, which is what happened previously. How much did we make? How much did we spend? I promise you, most of the analysis we do today, I would say, I dare say 70, 75, 80% of the analytics that we do today is descriptive. Another word for descriptive is historical. That is something that has happened in the past. So we are looking at history. This time last year, how much did we make last month? How much was revenue? How much was profit? How much was income? How much was EBITDA? How much was EBIT before tax? How much was this? All that is historical. Sometimes, another perspective to historical is diagnostic analysis, whereby we look at the why. Oh, why did we not hit our targets? Why did we not make adequate sales? Oh, it's because people are on holiday. ASU is on strike now. People who sell in universities will be doing a lot of diagnostic and descriptive analytics today. Okay, students have gone home, the taxi drivers will be looking at, okay, I cannot make money. Why? Because students are not here. So what do I do? Then they now do something to remediate that action. Or the students have, I remember when I used to have an Uber car, and my first driver told me something that he was a driver, a taxi driver, but they were not seeing right. And then some of them were thinking, what was the problem? But guess what? Everybody was now riding Uber and nobody was taking taxis anymore. Now, someone would do the diagnostic analytics and go to the village to do something, but he was smart enough to do the diagnostic analytics in quotes and see that, okay, the crowd has moved from black and yellow taxis in Lagos to cars that are air conditioned, and they can call and that will come to their house, and they're not walking to the junction to pick a taxi anymore. And that is where the crowd has moved to. So he did what? He followed the crowd. So we have a lot of options. Oh, why did we make so much sales? Why did we lose so much money? Why did we do, all sorts of information is gotten from descriptive diagnostic analysis. Now, predictive. This is what we try to do to look into the future. If you've ever accessed a loan from a bank, they tell you that, okay, we are going to check if your loan is approved. What are they trying to do by checking if your loan is approved? They are trying to see whether you are going to pay the money back. That's all they are going to do. And what are they trying to do? They are trying to predict whether you pay the money back. And I always use this analogy for those who have listened to me speaking in the past 3 months. They will tell you that if you are a federal government worker or a state government worker and you have worked for a few years, you are very eligible to get a loan. People love to give government workers loans. Why? Government never really owes salaries, and government workers don't resign. So they are good market for loans, as it were. But in places like Osun State, we've begun to see that government actually owns salaries. And in this generation of millennials, we have seen millennials who work with the government and then they resign to go and work in a bank. Well, there are not many in that scenario, but it happens. I've seen a millennial somebody who resigned from working as a civil service until tomorrow he curses the day that he joined the civil service because he's now making money. I'm not saying civil service is bad, but we're talking of people who deviations from the norm. So can we consistently now say that giving civil servants loan is a sure guarantee of getting your money back? No. But again, that is rule of thumb predictive analysis. So if we are doing strategy, we are working at FMCG, we are working at Coca-Cola, we want to distribute Coke, we want to distribute a lot of items. We need to start saying, if the Harmattan is very hot this year, what was the prediction of Harmattan? We've been saying global warming, global warming, global warming. What is the implication of global warming over the next few months or over the next few years? During Harmattan, has it been extremely hot? Or for those who live in the Middle East, where they are seeing temperatures of 40 degrees Celsius, 60, 50 degrees Celsius, what kind of planning do they do? I remember meeting someone who came from Russia, and he says, once the weather becomes dark, when you have long days, it affects his psyche, so he travels. I've seen places where during Ramadan fast, they either work for 5 hours or they travel. So a lot of people had a lot of behaviors that they do or exhibit during some specific situations. Now, predicting how people are going to behave or predicting how people are going to react with data is what we call predictive analytics. Prescriptive also is to say, if the data we have is showing us that this is what is going to happen in the future, what remedies should we do? If JAM did not hold last year, and we have 2 backlogs of JAM exams this year, what strategy should we deploy for JAM? Which means 2 sets of people have graduated, or students have graduated from high school, and they need to get into the university. What is the strategy? So, or if it is a long holiday, 4 days holiday, Mohammed's birthday plus Easter or something like that, and people have not been to the banking hall, what is the model for which we are going to operate after we resume? We saw a good example after COVID when they allowed us to go out, how the banks became a mess. But a bank who had tried to do some prediction or prescription would have gotten it right. I doubt if that was possible, but those are kind of scenarios that we talk about. Okay, so we move. So what is the analytics process? In every scenario, analytics follows a set of series. It's science, it's nothing complicated. We typically would determine what kind of data you need. Sometimes data is separated by demography, by income, by gender. It's separated by some parameters. And then it's also categorized usually. When that is done, we now collate that data. When that is done, we store it in a location. And we also, sometimes we have multiple sources, and we always store data in a location. The location can be a database, it can be a file, it can be somewhere, at least there has to be some storage of some sort. And once that storage is done, there needs to be some analysis of some sort. It could be a simple Excel sheet. It could be a database report. It could be SPSS that university academics use. It could be Power BI. It could be a whole lot of stuff. Then for some level, there's also some level of analysis that needs to be done. And this is at some advanced data practice level, where you need to check for duplication, you need to check for incongruent data, you need to check for incomplete data. That is what we call cleansing and all that. And then after that, we can now begin to put it in a format where we make decisions from it. So it's typically 4 or 5 steps. What do I need? Where is it located? How do I collect it? Where do I store it? What software or what tool am I using to analyze it? And then if it is for advanced level, how do I cleanse it? How do I maximize it so that I can use it to get more results? Okay, so let's dive into the various career roles that we have here. And apologies. Let's look at those roles that we have. So we talked about the fundamental roles in analytics. There are about 5 of them or 6 of them. We have the business analyst, and then we have the data practitioner or steward. We have the data professional, who is your typical database administrator, business intelligence engineer, your big data engineer. We have your data scientist or machine learning professional. We have those who are leaders in the data business. They are managers, they are senior consultants, they are chief data officers, they are things like that. It's also a career path. And then we have those who are into research and academics. 2 beautiful products that we use almost every day that depend a lot on data, which I'll mention later on, came from research and academics. And then we have some adjunct roles in data and analytics, which include data security and auditing and data governance. These guys are not necessarily data practitioners, but they play in the data space one way or the other. Okay, we have spent about 15 minutes, and I'm going to run through the various roles. I hope I can be done by 8 o'clock. So let's talk about the data of business analyst. I would skip the data practitioner or data steward because it hinges somewhere in between the data professional and the BI engineer, data professional and the data analyst role. So I didn't mention it, but I'll talk about it at some point. Okay, so who can be a data or business analyst? For those of you who saw the posts that I did, for those of you who saw the marketing that I did, I mentioned that if you have been worried, if you think you need to be if you think you need to be a rocket scientist, if you think you need to be a genius, well, I have news for you. You don't necessarily need to be a genius to be able to do this data science thing. And this, I promise you, is the most, not data science, data analytics thing. This, I promise you, is the most basic component of data analytics. If you are not afraid of graphs, you are not afraid of charts, you are not afraid of looking at data in 15 columns or 5 columns or 10 columns, and you can easily say, oh, I see this graph growing or I see this reducing. You can do basic interpretation of what you can see on a graph or on a dashboard. I promise you, you can be a business analyst. You don't necessarily need to be someone who has studied this course forever. So today, we see a lot of accountants, we see a lot of economists, we see a lot of real estate professionals, and those who study estate management. We see a lot of, what do I call them again? Business administration, actuarial sciences, who are just looking for jobs. But if you could have graduated, even if you don't have a first class or a 2-1, if you could have graduated without an extra year from a course that requires analysis or computation, you are left brain. Then I strongly believe, unless you were forced into that program, I strongly believe you can do a career in analytics. Not everybody's going to be an ICANN certified person. Not everybody's going to get a job in a bank as a salesperson or a marketer or as a treasury person. But almost everybody can get a role doing analytics because the roles are too many for us to fill. So it's not only for those who studied computer science. It's not only for those who studied all those hard courses or engineering courses. It can be for almost anybody, as long as you can look at a graph. Some people who do analytics and their work, I promise you, is not inside Excel. Their work is not inside databases. Their work is not inside dashboards. Their work is inside PowerPoint. Take the graph. Somebody has designed the report. Somebody has built the report. Take the graph, slap it into PowerPoint, and explain to people. There are a lot more people who don't like to see graphs. There are a lot more people who are too lazy to look at trends. There are a lot more people who are too lazy to interpret what is going on the system. So I promise you, if you can look at data and make insights out of it, you are in a 20 is even too big. I dare say that you are in a 10-15% percentile of people So if you think it's something you can do, one of the things I wanted to do here was to add courses, but I didn't have the opportunity. Just go to Udemy and look at a course of basic analytics. By the time you take 3 or 4 courses over there, you'll be fine. Udemy is always doing a promo. $10 courses, $15 courses, $20 courses. Nigeria cannot be so hard that you will not be able to get $15, even though the Naira is now 600. It cannot be so hard that you cannot get $50, even if it's to borrow. It cannot be so hard that you will use 1 year to pay $20, $20, $15, $50 back. And if there's anybody that's like that, I reject it for you, folks. So you can easily take a course analyzing employee compensation and benefits data. You can get a job in HR. Looking at attributes and characteristics of a product, as well as responsibility for pricing management. You can tell people that this product, you can see that this product is not selling well in this place. Some people just ship. A lot of Nigerians, especially or Africans, we just ship stuff. This is how we've been doing it, and we will continue to do it. Nobody analyzes why. So people will tell the company that this is the direction for the company to go in the next 3 years. Companies are usually making changes. Companies are usually taking decisions. Everything lies in data, and you don't need to be a rocket scientist to do this. Simple PowerPoint, simple Excel, simple looking at graphs and charts and trends. Sometimes the data does not even need to sit in your organization. The data can be somewhere online, curated by World Bank, curated by National Institute of Statistics, curated by World Economic Forum, or curated by the United Nations. You just need to pick it, look at it, and tell the trend. Boom. The other role is the data professional. These are people who operate data every day. They are core technical guys. They are database administrators. They are business intelligence or data warehouse guys. They are big data engineers. They, at some point, usually understand how servers work, sometimes, but not compulsory. So if you're an engineer, if you study computer science, and everybody is now doing web design and JavaScript, and it's too much, and you cannot even get a job. I know banks that are looking for people for 3, 4 months, 6 months. They are looking for database people. And one trend now that I have seen, before it used to be marketers that move from one bank to another. Now I'm seeing that the data space is so small that I will work with somebody in a bank today, and in 2 months' time, I'm working with the same person in another bank. And in another 4 months' time, another person that I worked with in the first bank is in a third bank. So what is happening? There's a rotation and recycling. Why? Database guys are rare. Database guys are not many. So it is a skill set that is not saturated. It is a skill set that is in high demand. Business intelligence, data warehouse engineers, these are guys also that do dashboards, build data. When you have your data in the bank, your reports from your accounts, your data from your internet banking. There are people who merge all this data together to make sense out of it for the sales people, for the regional people, for the management of the bank, and build this data into a large format where it can be easy for the end users to be able to build their reports and dashboards. It's different from the business database administrator. They both play with databases, but their works are different. So these ones use data warehouse, while the first guys use databases, Oracle, SQL Server, DB2. But these guys are using DB data warehouses, SAP, and some other things like that. Then the third ones are the big data guys who manage large volumes of data. For those of you who are connecting from abroad, if you have lived in a country where you get fines for traffic offenses, probably you skipped the red light or you committed a traffic offense. Many times, the fine does not come immediately. Why? Because for the camera to capture your data and then send it upstream, a lot of background processing is done. This is where these guys play. So sometimes your fine does not come until 30 days time. Your fine does not come until 2 weeks time, because it is a lot of background processing. It is the work of these guys to process that data. Or Russia is transporting energy from Russia all the way to Germany. That is like traveling a journey that will take a plane about 4, 5, 6 hours. They are using pipelines, they are using pumps, they are using sensors. How does that data get transformed and translated? Or Shell is drilling oil in the well. And how do they want to know what is happening in that oil well without anybody sitting there? You say it's robots, yes, robots. Or you say it's sensors, yes, sensors. But the sensors are not eating the data that they make. They still send the data to human beings. Or an aeroplane is flying, and every aeroplane is passing data and sending data back to base at every point in time. This is where I am calling home and sending information. It is these big data guys that manage that data, and they process it in such a way that people can be able to understand it. When a plane sends you data or an oil well sends you data 24 hours a day, or a base station, MTN base station is sending you 24 gig of data every day. How much, or 24 gig of data every hour? How much of it do you want to read? Somebody needs to massage that data, kill the fluff, take the sense out of it. Sometimes out of that 24 gig, it might only be 1 gig that we need for use. Somebody needs to transform that data and massage it and give it insight. That's a big data engineer. Now, the deep, we're going deeper. We have the data scientists, who are the guys that are doing some complicated work. Their work is somehow similar to the big data guys, because they also pull data. Now, data science suddenly became a popular profession in the past 3-5 years. Why? Because some academicians and some researchers made public some systems that allow data scientists to use statistical methods to analyze large chunks of data. Before, data scientists could only look at files, small sheets of data and everything. But based on research done at Google, they made it open source. Now, data scientists can now access 40 gig, 100 gig, 1 terabyte of data, pick samples of that data, be able to make predictions, and be able to do all that kind of stuff. Now, if you want to be a data scientist, you must be able to understand statistics very well. You must be very comfortable with statistics. You must be able to do things around regression, classification, clustering. You should be able to write a Python script or R script. I prefer Python. You must be able to know how to use all this clustering and regression stuff and apply it to machine learning for prediction. You must be able to make complex abstractions. You want to predict where the stock market is going to go in the next 5 years. You want to predict how a fund is going to perform in the next 3 years. If we invest in this money, in this business, or in this something, what are the projections that you are making? Yeah, they may not go well, but again, sometimes they go. You get into the airport, in some places, a camera snaps your car and then automatically generates a plate number, your plate number, and then generates a ticket all within the space of 30 minutes, or I mean, 30 seconds. Where does that data go? Or you jump a traffic light and it captures your camera, or people are passing a traffic light every day and we're analyzing what kind of cars are going, what kind of cars are passing. For example, one of the data samples we are going to evaluate tonight is New York taxi data. How did they get that data? What kind of insights can we do? What kind of predictions can we do? How can we budget for our roads? How can we budget for our city with taxi data? Should we get more Ubers? Should we get more Bolts or more Lyfts? What are the things that we can do? All these things are information that data scientists use. Okay, now we go into research. These guys are the lecturers who taught people like you and me, who studied computer science. We also have better ways of processing data for business use, for military use, for academic use. We also have people who use research techniques. Now, for those who do masters, if you have a master's holder or a PhD holder in the room, there is a strong component of your course that is on analysis and research techniques. I won't go deep into details because I'm not as learned as you, but I know in the PhD course, for about 6 months or 1 year, or almost a whole session, you are learning how to do research. So research techniques is a very, very big thing in academia. So for even those who are not in data and analytics, they learn to use data and analytics. Now, those who are now into data analytics now go a notch higher. Google today, while we think Google is search, Google is actually data aggregation. Now, the data they are talking of is not about charts and graphs. It is information that is all over the world. How can we harness that data and index it and put it in a directory to say, this information is here, that information is there? Google was from a research process. you will see that the owners of Google, Sergey Brin and Larry Page, they were PhD students at Stanford. Was it Stanford or MIT? I think it was Stanford. So you can see that, you can see what the world has turned into. Google has even entered the dictionary. I will Google it. I Googled it. I saw it on Google. It is a noun, it is a verb, it has present continuous, it has present perfect because of this. There's another one that is the formalized version of data lakes, which is Databricks, also from some PhD students or researchers in Stanford. And it is what many organizations that have cloud platforms are using for their data lake systems. It's called Databricks. It also came from a project in academia. The guys left their academic work and then they went into business. Of course, they failed, but again, they got business people to come and support them, and they are having a very nice marriage. Analysis and business professionals and academia working together and making a whole lot of money. A whole lot of money. Then, of course, the data leadership. We have roles like the analytics manager, director of analytics, or the chief data officer. Here, you are deciding, for example, what tool your organization will use. Are we using Power BI? Are we using Tableau? How do end users get access to data? Once data sits inside the server alone and only the backend guys have access to it, how can we make data accessible to the analysts? How can we make data accessible to anybody who needs data? How do we ensure that data is secure at the same time? How do we ensure that our company is a data-driven company? The CIO of InterSwitch was talking last month, and he said in his organization, it's not been easy, but they have been using data and analytics a whole lot in making all the decisions they are making. And you can see how InterSwitch is making trends and strides in that business that they are. They are very much on parallel in that industry that they are. So at some point, when you have played in all those roles that I have mentioned, you will definitely end up somewhere here if you like leadership, you like people, you like politics and all those management stuff that happen. Okay, lastly, we now talk about data security and governance, where we talk about creating data policies, data strategies, making sure that data is protected, assuring that data is not leaked, assuring that data is not stolen. I usually give a scenario to say 2 people resigned from a company. One drops the corporate laptop but took a database backup on a flash drive in his pocket and walked away. The other person did not drop the corporate laptop. He literally stole it and went home with it. Which of them committed a greater offense, or which of them did a bigger damage to the organization? A lot of people will say, oh, the guy who took both of them. But I say, yes, both of them did something not appropriate, but one did more damage. Of course, it's the guy that took the database away, because that is a whole lot of information from everywhere. And these are the kind of things that we are talking about. So somebody needs to ensure that it's very difficult or almost impossible to steal data. Or if there's a hack on the network, people will not be able to steal or access that data. Let me give an example. Garmin, which is a mapping company, they have a smartwatch and they have, so these were the people who used to do mapping before we had Google Maps. For those who are abroad, they have what they call TomTom, which is like a GPS device that tells you how to go and where to go, but Google democratized mapping. Now, a lot of people use them because they go into extreme places, they go into extreme locations. They have mapped almost all the whole world before Google came and overtook them. Then because, of course, they have a fitness section also, that means health details of people are stored in their system. Now, they were hacked the other day, and somebody asked them to pay a ransom. Imagine if somebody has access to all that mapping data. Imagine what that would be or what that would cost. They didn't tell us how they resolved it, but again, we know that the ransom they were asked to pay was in millions of dollars. Another hack that we were told about was that of an SPG, which is a loyalty brand for people who travel and go to hotels. So if I go to a hotel, my loyalty points, I get points for using that hotel. The Marriott hotels, the Le Méridien Hotel, the Sheraton hotels, and those hotels. Now, they were hacked. Imagine if somebody gets access to all that hotel points and everything. Just imagine you having access to that, which means you can go to almost you can go to a hotel and live there for 1 year on points for free, stealing somebody's data. So anytime you feel like when you just go to 4 points in Lagos and you sleep, or any country you find yourself, just look for the Meridian, the Marriott and everything, and go sleep there if you are able to access that data. So somebody needs to ensure that that is not possible. Somebody needs to ensure that that is every organization that has data is aligned. So these are the things that these guys do. Okay, so we come to the end of this journey. So these are the various professions that we have. We have the data business analyst, we have the data professionals, we have data scientists, we have data leaders, we have the researchers and academics, and we have the data security and data governance guys. That brings us to the end of this particular section of today's meetup. I would like to know if anyone has questions. Please let us know that we are in a meetup environment. Let us unmute ourselves. Let us ensure that we don't have background noise, and then let us present our questions. Thank you, everyone. So you can unmute yourself if you have questions. Or you can drop your question by chat. Okay, Dari, are you clapping or raising up your hand? Okay, Dari is clapping. Thank you very much, Dari. Okay, thank you, JT. Don't know what JT means, but thank you, JT. Okay. So do we have any questions? Thank you, Theophilus. Nobody has any questions. Are you suggesting that I did a very, very great job?
Hello.
Finally, thank you, Maria. Yes.
Hi, everyone. Thank you so much for that presentation. It was quite an insightful one for someone that wants to be introduced into the data space. My question is, you've talked about the different aspects or fields in data. Are there processes or are there roles? Because I believe that it's not a new space, but a lot of people are new in the space, kind of, especially for us in Nigeria. Is there a path that someone would take in occupying each of these positions? Let me give an example. Would someone just say, oh, today I want to go into data governance, or I want to go into data engineering? Or is there a hierarchy? Is there a hierarchy in these positions that we need to take cognizance of for someone that wants to go into any of them? I don't know if you get my question.
Yes, I do get your question. Yes, I do get your question. Sure. Yes. The response is yes, and the response is no. So how do I mean? You have asked that, is there a path, a defined path that somebody needs to follow? And is there a hierarchy that allows someone to like grow in this thing? So the reason why I said no, I'll start with my no, is because as you can see, I have, 1 second please. As you can see, I have tried to make life easy for everybody by going through various various patterns and various components. One thing I'm going to do by the time I'm sharing this file is to tell you what kind of courses to take for each of those job roles that I have listed over there. I didn't want it to be too long, so but I'll do that before I share this file to people who came for the lecture. Now, there is, I would say that for each career path or for each job role, not career path, for each job role, there's a skill that you need to learn and need to master. But there is nothing that says, oh, you were, let's go back. You were a business analyst before. You have now grown to be a data practitioner or a data steward. And you have now grown to become a data professional. No, there's nothing like that. If you studied computer science and you are not afraid of data, you can easily become a data professional, like that. If you are able to learn programming or learn whatever you want to learn, you can easily become a data warehouse or a BI engineer, like that. We have people who will go and take data science courses, and within 3 to 6 months, they begin to write data science, data models, build models. They're not afraid of statistics. They're not afraid of anything. So I would say that each of these things that you are seeing here, are you with me? You can actually approach them directly. The only ones that you may not easily approach directly are those data leadership. You cannot suddenly become a data leader if you've not done anything around data before. Now, today, it's possible for someone to become a CIO, a Chief Information Officer, or a head of technology. We see it a lot. And CIOs are not technical people, they are business people, for example. Now, those people, why? Because they're just thinking of how to make use of technology for business, or how to make the business enjoy technology. It is going to be a tough call for you to be a chief data officer or an analytics manager if you have not had a background in data analytics. Yes, you can have people under you reporting to you and everything. The pattern that we have seen today is that people who become chief data officers are usually data scientists or big data engineers. So that is a kind of hierarchy, but it does not necessarily guarantee that you have to be a big data engineer or a data scientist. If you've been a database administrator or you've been a data warehouse engineer, you can also become a CTO or a director of analytics. So that is the only area where, of course, you need to follow a kind of hierarchy. Of course, you cannot be doing research that would give us the kind of result of Google or Databricks or Snowflakes and not have tenure or follow a career path that has made you grow. So like I said again, it is only these last 2 ones that I see you having a kind of hierarchy. But for the other ones, you can choose that I want to be a data scientist and work towards it. The same way I would say I want to be a chartered accountant and work towards it. You don't necessarily need, just like in accounting, you don't necessarily need to do tax before you do audit, before you do investment. You can choose to be a tax person and go to tax straight. You can choose to be an audit person and go to audit straight. I hope your question was answered.
Yes, that's clear. Thank you so much.
You're welcome. JT, I can see your message. You started a couple of online courses, but you didn't see them through. Maybe you would need mentorship. Well, yes. So sometimes people get inundated by some of the courses they do. So they just buy the courses, either out of fear or out of panic. I met someone 3 weeks ago who has worked around data, and then he's considering doing something in data science and analytics. So when it was meant to be a kind of mentorship call, and then I said, okay, no problem, that's nice, interesting, let's see the outcome, let's go. How old are you? 39. How many kids? 3. Married? Well, that's fine. If you think you can do the dedication of 3 to 6 months, let's go. But are you sure you really can dedicate yourself and do that? Maybe that's not the best thing for you. So imagine if that person didn't get to talk to me and he invested in a data science course, or he invested in an analytics course, he probably will get bored and run away. I, talking to you today, I personally chose that I'm not going to be a data scientist. and I'm not going to be a big data engineer because I don't like statistics. I don't like some level of mathematics. So I am not going to be there. I'll understand it. I'll know how to use it. I'll know how to govern it, but I am not going to be a practitioner. I chose that path. So yes, maybe we may need to have a one-on-one conversation. You can send a message to the team. We'll have a conversation with you and see how we can support you. Okay. Any other questions? Any other questions before we go into the demos? Okay. Thank you. So in the absence of any other question, I'm going to end this presentation. Thank you so much. And so the next thing we are going to have now is the demo. Like I mentioned, the demo is going to be a bit long because it is going to show you how to use data to, we're going to take raw data. The raw data is from a data source, which is taxi data in the US. And this was done by Bisolu Adekoya. Bisolu Adekoya is a data analytics architect. He's currently based out of Canada. He was not able to make today's meeting, so he has graciously done a video recording for us, which I'm going to play. It's about 15 minutes. But what I want you to watch is how he's going to take the data from raw format, and then he's going to put it into a location. Then Adewale Yusuf, who is one of the best data, we call him a data bender, who's one of the best data analysts in Nigeria. He's a Microsoft most valuable player in data analytics. That means he's so good that Microsoft recognized him and they said, you deserve an award. He's going to take that data that Bisolu has played with, and that data that Bisolu has played with, which is raw data from CSV format, pumped like big data format. I remember when we were talking at before this meeting, he said that the data that he's processing is about 130 million rows. Let me just check. How many rows did he say it was? 170 million rows. 170 million rows. So we are processing 170 million rows of data. We are pushing them into a system. And our friend Adewale is going to take that data and he's going to analyze it and build a dashboard of it. So I'm going to play this now. If you cannot hear it at your end, please let me know. And we'll take it up from there.
Hello everyone, and thanks for being here. For this session, I'll be leveraging Azure Synapse to showcase how we can easily ingest data from any source really and make it available for analysis in Power BI. So Azure Synapse is an analytics service platform that allows you to ingest data, create data pipelines, transform data, create aggregations, do machine learning, optimize machine learning models, and this is at scale using either dedicated resources, which are a bit more pricey, or serverless resources. So another thing about Synapse is the how Synapse is configured is there's a workspace which is like the Azure resource itself, and there's also a studio. So all data engineering or data analysis activities are performed in the studio. I'm going to show how the studio looks in a minute. But for now, let's dive in and see how we could spin off an Azure Synapse workspace. To spin up a workspace in Azure, you need access to an Azure portal. You need access to a subscription, either a free trial, your organization subscription, and you need access to your resource group. So once you have access to your resource group, you could log into the portal. As I've logged in, this is exactly what you're going to see, or something similar to this. And I can start looking for where Synapse. So I can search for Synapse, right, using the search bar at the top, and SYN, and it comes with Azure Synapse Analytics. and I click on that. I have one existing, and I can click on create to create another one. So I'm just going to show you the process. You need to fill out the this form to have a workspace created for you on Azure. So it's going to ask us for the subscription. We have one already, and for a resource group, you can create a new one if you have that permissions to do that. And I have one existing already, so I can reuse that. And I'll just focus on the required fields for now. So the workspace name is got to be a unique name. Yeah, let's see. Does that exist? Yeah, and I also like to prefix my resources name in Azure with some kind of a naming convention. So I can prefix it with SYN dash. You also pick a region. You might have a standardized region in your organization, or you could put your region close to the data you want to ingest. For this session, I'm going to ingest the New York City taxi data. So I'm going to select East US. I think it's in East US, but there are a couple of other regions you could use. And I'm also going to create a data lake storage. I think I have one already existing. Yeah, so I select my existing data lake storage and reuse my file system name. I can also create a new one here. Then I go to security. Security is just a way of making sure that your workspace is secure, right? So I can use both a local admin or an Azure Active Directory admin. So select the admin here and put in the password. Yeah, and you could also encrypt your data, right? So, but for this section, I'm just going to disable that. The networking is how your workspace can be accessed over the internet through a VNet, through a private network. Only specific IPs can access your workspace. If you want that, you need to uncheck allow connection from all IP addresses. Then you manage your firewall on your own. Then finally, tags. Tags is just a way to categorize or to organize your resources when it comes to billing, or when it even comes to creating logs and tracking your resources. For this session, I'm just going to leave the tags empty. It's not a compulsory field, but it's best practice to have tags. And finally, I'm going to click on next, review and create. So if everything is good, I'm going to have a green validation succeeded. Yeah, I have that, and it's going to give me an idea of my bill, or how much it's going to cost to run this service. So I have one already created. I'll switch over to that. So once that is created, you're going to have this this same page I'm looking at, where you have the huge buttons ingest, explore, and visualize. But I'm not going to go into these three for now. I'm just going to go into the knowledge center, because there are a lot of interesting stuff in the knowledge center. So when I click on the knowledge center, I go to browse gallery. Galleries is a very interesting place to learn, to see what is new in Synapse, and also to kickstart of projects. Like if I'm going to do a project for a bank, for example, I can click on banking just to okay, what is in banking, and it shows me like the structure of a bank's data warehouse, right? Like at a very high level, really. So here you have employee channel. These are tables pre-created for you in Synapse. All you need to do is create database, and you're going to have all these tables automatically created and automatically having data in them as well. And you can start analyzing them or start building like your prototype out of them, and even updating them or making them the way you want them to be. So yeah, so this is building a database, but I'm not building a database for this session. I'm just going to I'm looking for a data set. Like I said, I'm interested in the New York City taxi data for this demo, just to showcase how easy it is to ingest data into Synapse. So I can see that New York taxi here, yellow taxi trip records already. There are a lot of other data sets you could work with if you're interested in that. Like there's COVID-19 data, there is public holidays, interesting. There is a lot of other things, diabetes and stuff like that. So for this session, I'll just go with the New York yellow taxi and say continue. And it's going to tell me, give me an idea of what I'm to expect. So it's telling me that the volume of this data is 1.5 billion rows, and it's like 50 gig in total as of 2018. So I know this is huge. Okay, I'm interested in that. Let's see how this work out. And once I click on data set, it's going to create a set of scripts. I already did that, so I'm not just going to do that again. It takes like 4 to 5 minutes to load all that data, which is pretty fast considering the volume. So when I go to my develop tab, this is where you have your scripts. There's a load New York taxi cab data here, and this is the script that the gallery generated for me automatically. It has a script to create a date table, a script to create a geographic table, and medallion, time, and the trip itself. Yeah, this is the fact table. And also there is weather. If I'm interested in what the weather was during that trip. So all these are created with the standard data warehousing techniques where you have your surrogate keys, primary keys, so they're all linked by keys or IDs. And so those are the tables, I think like 5 or 6 tables. Then the interesting part is the ingestion of the data itself. So once the tables are created, the next step is to load the data into the data warehouse. And interestingly, there's just a copy command or a copy statement in Synapse. I just say copy into date from, and you provide the location of your source data, right? This could be any location, like it could be whatever location you want it to be, an Oracle database, a data storage, an Azure blob, anything. And with that command, once you run this, it starts copying straight away. Same thing for the geography table, same thing for every other table that is there. Even the weather itself, you can just type in that copy command and it starts copying. So once it's copied into my database. My database is located under the data tab, and if I go there, I have a sample SQL database. I can see here that this is the only database I have, and these are the tables that were created. Now I can come in here and say, show me the top 100 rows in this table, and it shows up instantly. You are looking at millions of rows here, and it's coming back pretty fast. Yeah, because I've run this query before. There's a caching mechanism in Synapse as well that makes this query fast the second time you run them. So this might not be a true time for how long it takes the query to run, but it shows that once I run this query once, second time it's just going to be pretty fast. So I can change the top to, let's say, 200 and see, maybe I'm going to get the same response. Okay, yeah, so that increased by 1 second. Yeah, okay, so the data from the New York City taxi that's in your remote location where Power BI cannot reach it, it's now available in our data warehouse where Power BI can easily connect in a more structured environment. Now we have tables with primary keys with relationships all built in here, and I can start doing modeling in Power BI, which is going to be the next session that you're going to have. So for this is pretty straightforward and simple, where we just need to ingest this data just to, let's say you are building a a prototype, like, okay, this is how our data wire is going to be, this is what we are going to do, this is the script. And you can also collaborate here. Like, a lot of people can log in here, and we can see what each other person is doing. We could also link this to a repo where we can have source control on all of it, but we won't go into all of that for this session. And if we have Azure storage as well, like, it's automatically linked to my storage. When I go to linked tab, I can see my data lake storage. I can go to my data lake, and I can easily see data in my lake, right? I can even query data in my lake straight up without, so yeah. And it creates so the good thing here is all these queries are like gives me an idea of how to write my own query if I'm not familiar with it. It's also a learning process. Like, you can see, okay, it's using a command here, open set. It's telling me the where I put in the endpoint to the file. And also, this is not the only language that you can use in Synapse. Synapse supports SQL, which is what we are using. You could also use Python. You could use Scala. You could use .NET, C# specifically. And yeah, so that is it. That is Synapse. It's an analytics service that allows you to do all these things on the fly. Like,
Okay, thank you, everyone. I guess that was some good insight for you. So you are able to see how he has pumped data. Now, the scenario here is a scenario whereby he has taken data. Now, definitely he used sample data for this, but imagine if the data he used was data from your bank or data from your company or data from wherever you are, and he's now allowing you to use that data to be able to begin to do what you want to do. So this is a sample of pulling data from CSV files. You can see that the source data was 50 gig already. If you don't know what 50 gig means, 50 gig means the size of the total space on some people's phones. 50 gig means 25 high definition movies, if it is 2.42 gig, or it is 10 high definition movies that are 4 gig size. So this is something that you cannot even put on a flash drive. You need an external hard drive to put it. As a database administrator, if I have a database that is 50 gig, it's not too big, but it's not something I'm going to play with. So you can imagine, and that 50 gig now turned into how many rows? 170 million rows. So that is the first step. And then let us move to Adewale now, who is going to give us how to build a dashboard out of it. I hope you are enjoying this, and Adewale, over to you. I believe you can share. Please share your screen and
please confirm you can hear me clearly.
Yes, I can hear you.
Okay. Thank you so much for the opportunity.
Yes,
Thank you. Thank you. So thank you so much for the opportunity to present. I'm going to share my screen now. And let me know when you can see my screen.
Positive, you can see your screen.
Yeah.
Let me know when you can see my screen.
Positive. Yes.
You can see it.
All right, so thank you so much. I'm just going to show us a demo on how we connect to the data on Synapse that was already being created by Bisolu. So it's kind of easy because all the data warehousing and different data, even ETL and everything has been done. So we are just connecting to a dedicated pool on Synapse, which Power BI can connect to and do a lot of analysis. So as we all know, for the people that are new to Power BI, to connect to a data, what you do is you come to your home tab here, and from your own tab, you click on get data. But if you look at this, everything that we have here, it's fine, but what we need is not here. Remember, we are trying to connect to Synapse. So I'll just click on more. So you see the way I'm going to connect to that. Right, so here I'm going to search for Synapse. And here,
sorry, Wally.
yeah, can you hear me?
The only one, yes, but I'm seeing the dashboard. I'm not
Can't see how you are checking. Oh.
Oh, you can't see what I'm doing. Wow, okay. So let me stop sharing and share again.
I think your screen froze.
How about now?
Okay. I
Perfect.
think
What
it's
can,
better, yeah.
what can you see now?
Get data all Azure.
Yeah, we
Oh,
can see
okay.
it. Right?
Can see,
Okay, so what I did
yeah. Okay.
basically, let me cancel it so I can do it again. So what I did basically is just to come to Power BI Desktop. I click on Get Data, and from here I click More. I want to see more connectors in Power BI. Then from here I type Synapse, since that is what I want to connect to. And here you can see Azure Synapse Analytics SQL. So because the query was created by a dedicated SQL pool, so I have to connect to Azure Synapse Analytics SQL. If it was created by workspace, like pipelines and all that, I may need to use this particular connector. So this is the connector I'll be using, and I'll click on Connect. And right here, what I need is basically simple. So I need a server name and I need database name. So I have that in somewhere here. Let me just quickly get that. Okay, sorry if I'm not sharing my screen right now. I'm just trying to protect some data. Okay, so just 1 second. All right, so I have my server and then my database name now. So if you can look at my screen, this is the server name from Synapse, and this is the database. So I can try to do import or do direct query so that I can connect to the 170 million rows of data that we currently have in Synapse. So I would like to do direct query for this. Although I have already connected to this data and pull like just 3 to 5 days because of the heaviness of the data. So I don't want to waste our time in the demo session. So I can just do a direct query now and click OK. Okay, so let me see this. So my server is complaining. All right, so let me click OK. All right, so I've connected to a direct query now. So Synapse is going to ask you to actually validate your credentials, but I've already done that already. So credential has been saved in this current Power BI desktop that I'm using. That is why you can see that all the tables that Bisolu mentioned, you can see all of them, the date, the geography, the Acne license, the medallion, and everything, right? But just for the demo sake, I'm just going to tick some of the table. I may not take everything. So date, geography, time, and trip. So I'm just going to click this 4 different table and I'll click on transform. Okay, so once I click on transform, so you can see all the data here. So this is 170 million rows of data that you can see here, right? 170 million rows and connecting to Synapse Street. So this is also the time, the geography and the dates basically. So for this one, I can change this United States to something else so that I can actually match with my map. So I will just say United States of America. I'm just doing some little cleanup here, and I don't want unknown here. So there's also an unknown stuff here, so that I don't want to bring into my data. Then I'm going to load this basically. I'll load this to Power BI Desktop, and you see how this table will show here.
I think we lost him.
Let's give it like 4 minutes. We believe we will come back. He's back. Adewale, are you back? Hello, Wally. Everything okay at your end?
Can you hear me now?
Hello. Yes, we can hear you.
Hello?
Yes, we can hear you. We can hear you.
Okay, so I think, so sorry, my network. Okay, all right, let me share my screen again. Let me know when you can see my screen now. Can you see my screen?
Yes, I can see your
Yes,
screen
we can
now.
see.
Can you see my screen?
Yes, please.
Yes.
The direct query is trying to load right now. Maybe that's due to my internet glitch, and it's a direct query that I connected to. So that's why it's not showing yet. So let's just hold on for a second. Okay, so while we are waiting for that, so I don't take too much of your time, I've already connected Power BI to the data source, right? I'm already connected to that, and then I will just show you the end result of that. So what I showed you before was just to connect. So here, if you look at my screen here, I just have a simple does a forecast on the total number of trips that we have for some certain number of days, right? So you can see the trend of our trip and how this trip is going. And then using Power BI for this is truly telling us that in the next day, actually, so this data we have here end at 31st 12 of 2013. Now, let's check for 2014 of the we have, and this forecast is showing that we have 5 that we kind of forecast, which is table if it's loaded now. So how is this created? It's not something hard. What data that I connected to take so much time when I'm trying to load this because of this is kind of simple. It's not something so hard like that. It's not something that you need to do a skyrocket before you can actually do it. So it's something simple. And how do you do that? So I already have a wireframe created in PowerPoint. Put into design. It's just for design sake. And for the analytic part, so I just write some basic measures. So I call them basic measures because they are not really that advanced. So I have the amount, which is just to sum up the amount. I have the average fare. So this is just calculating the average fare amount for all trips. I have the distance, which is just the total of all the distance mile. And I also have the average distance per trip. So this is just showing the over my miles on the country. So to give me more information about this country, the average distance, the total distance, the trip, the average fare amount, and some information and even the trend. So creating this is extremely simple. So I'm going to put an example of the forecast right now. Line chart here. Put for forecast. And here I'm going to select dates, which is what I want to look at. So I want to forecast by date, right? And that date is by what? You can decide to forecast by whatever you want, maybe by fare amount, by total amount, but I'm more concerned with trip, right? So we can reason. All right, so this is the current trend that we have based on the optimized. So this is just 6 data points. You can see it's just 6 days. And from these 6 days, I can decide to even forecast to maybe another 6 days or another 5 days. So to do the forecast, you come to this analytics button, right? There's a button here called analytics, right? So from this button, you will see something called forecast down here. So I'll switch it on and points that I want. So I would like to show just 5 data points, which is like 5 days more. And then do I want to ignore the last? No. Did I want to put seasonality into play? And I can put percentage for seasonality or maybe a point for seasonality. And what's my confidence interval? Okay, let me just say I'm confident at 85% we should be able to do what we've been doing in the past. And once I apply this, you will see the different data points for the next other points, January 8, January 10, and even January 11 and 12. So if I hover my mouse on here, you can see the forecast number. So the previous amount before the forecast, right, is 399, right? So the next day after that, so there's a probability that I'll make a trip of total trip of 403 from this particular visuals, right?
403,000.
Yeah, you were saying something, Tosi?
403,000 trips.
Yeah, so I would not like to waste our time. So maybe what I'll just do to finish up the analysis and put it online for us to just play with and look at it and see what we can do with it. I think I should stop here because we spent more than our time already. Or what do you think, Tosi? Do you think I should continue?
You've done a very good job. So don't disconnect here. I just want to show people what we have done in the past 30 minutes. So
yeah,
what we have done in the past 30 minutes is that we have gone from a data engineer, which is like a data practitioner, somebody who deals with data every day, which is what Bisoli showed us. That means you have a lot of big data, 50 gig of raw data, and you have pumped it into a data system. Pumped it into a data system, and that data system is about 170 million rows. Now, what Wale has now done for us is to say that, okay, this data that we have, that is 170 million rows of what? Of nonsense making data. We can see what this only shared was just a row and a column, rows and columns. What do you have to do with rows and columns? So what Wale has done now is to pick this And this is the job of a BI engineer or a data analyst or a data steward. And he has done the work of a data steward or BI engineer, and he has built a dashboard. Now, typically when you build an Excel report, it's usually like, oh, I'm meant to share my screen. Okay, no problem. Yes, just over there for me. Thank you, Wale. That place that Wale is hovering on, where you have the blue table. Typically, this is what you see in Excel. But analytics has now gone beyond. Analytics has now gone beyond just rows and columns and a table. It has also been able to give you what happens on the bottom left, where you have your traffic on Monday, Tuesday, Wednesday, Thursday, Friday. And of course, he's now even able to put it on a map. So you can actually, if he decides to use a map, and he has shown you what happens only in the United States. And then he has now done some data science, basic data science work, which says we can predict how much traffic is going to be on the way. So if it is in a country or a city that makes sense, that they know how to use data, they will have predicted what is going to happen on this particular day. Maybe they are going to divert traffic in a particular way. Maybe they are going to make sure you have more policemen on the street. Now, imagine if LASMA was using data in Lagos. Imagine if LASMA was using data in Lagos. Imagine if police was using data in. So we were seeing that during the last few days of the year, the data was 309,000 rows. Then at some point, the data jumps to 400 and something thousand rows. So which means there needs to be more officers on the road, or we need to clear the road more, or we need to do some adjustments. Or maybe we even need to have more trains. Why should we be having 400,000 trips in a city in one day? Maybe we need to now start using water more, you know? All those kind of innovations are what we have done. So he also showed us a PowerPoint slide where he's going to copy these good stuff that he has done and he's going to put it on the PowerPoint slide. So imagine me now, I can look at this slide and I can tell you a story of how taxi work has gone in New York City over the past few months. I don't need to know anything about data. The people and Adewale have done all the hard work. All I just have to do is to copy this thing, paste it in PowerPoint, and give a report, an analysis in a small, nice note that say, this is the reason. Why was traffic lower on December 31st than on January 9th? Of course, people were on holiday, people were not traveling. Why was traffic high on January 2? That means, or January 4. That means because people were going out, people were hanging out. It was holiday time. People were going for parties, going to eat out, going to have fun, going to do all sorts of stuff. So these are the kind of insights that we can get. And I promise you, if you can just key into one of these things, you will be able to jumpstart your career in data and analytics. Thank you very much, Wale. I'm very grateful. Thank you.
Thank you so much, Tosin. And to add to that, if you look at the time as well, so this strictly tell you the time that people actually bought the trip the most. So if you look at this particular time from 12 to 12:59 up to, this is like early in the morning, right? So you can see that we have minimal trip here. So the day that has most trip for this kind of time is Saturday, which is weekend. So
people are coming back.
Yeah, so you can see the time where we have most trip, and you can see the color that determines how trips are actually going in terms of time. Yep.
Hold on there, just hold that thought. So let's even play a data analysis. Let's just quickly do that for 2 minutes. So we can see here now that the amount of trips, taxi trips that are happening on a Monday morning is even between 7 and 8 a.m. is less than the amount of taxi trips that is happening on Friday night to Saturday when people are going to club. They are just going to club at that time. So it means that the same amount of officers or the same amount of towing vehicles or the same amount of people we have on the road on Monday morning is almost the same amount of people we should have on the road where on Friday nights.
Wow. Wow. Wow.
So which means, let's assume this is Lagos State. You should be seeing LASMA on the road on Friday nights. Let's assume this is Lagos State. Now, I don't need to have a PhD in data analytics. It is just common sense. We can also see that the same amount of traffic we're having between 9 and 10, between 8 and 10 a.m. in the morning is the same amount of traffic we are having in the night on Friday. So on Friday nights, people have to work double shift. Predictive. They have to work double shift. They can close early on Saturday, on any other day, but on Friday night, people have to work double shift. Guess what? Saturday morning, people are back on the road. Not too much, but about 60–70% of the crowd. But guess what? At 10 o'clock on Saturday morning, it is the same traffic that we are having at 7 o'clock on Wednesday, Thursday, Friday morning. So the same amount of people that are going to work is the same amount of people that are going out. So we cannot say that it's Saturday morning, less officers. It's not possible. It's the same amount of officers. Much more officers on Monday morning, a little bit less on the other days. This is what data does for you. Does it make sense? Now, just imagine this is simple, basic data analysis. It is not because I studied computer science. It is not because I am a genius. It is not because my IQ is 175. It's just because I have opened my eyes and I have thought deeply and I'm able to make insights. The same way you look at your bank account statement and know where your money is going. It's the same way you can look at this data and you are able to say, this is what the problem is, and this is the decision we should make. I promise you, this thing that we have just done in the past 3 minutes now gives a lot of people headache. All right, Wale, final thoughts before we close this demo session.
Final what?
Final comments? No other comments? Any other comments?
Okay, no, not really. No other comments. So I'll try to finish up this dashboard and probably send it as a resources to you maybe later in the week, so we can share with everyone to play with.
Thank you so much. All right.
Yep.
I'm looking at the top right column of my clock here. It seems like we are approaching 2 hours on this call. Thank you so much, Isolu. Thank you so much to Wale. Thank you so much to everyone who has joined the call today. We started with many more people, but the number has gone down. Maybe people are bored, maybe we are taking it too long. But I know that for those who have attended, it has been a wonderful session for you. We would be closing now. Do we have any comments, questions, or inquiries? My team will drop the link for inquiries here. And if there's no inquiry, you can easily send a link, a mail to Analytics Africa. Just reply that email that sends you an invite. You can easily send a message to Analytics Africa at outlook.com, Analytics Africa at outlook.com, or you can send a message to us at contact us at analyticsafrica@gmail.com. Yes, so at analyticsafrica.org. So these two locations are where you can hit us and we'll be able to respond to you. If you have any comments or feedback and everything, we'll be glad to attend to you. Thank you everyone for coming around today. So, thank you everyone. And oh yes, Maria, it would be, thank you Yinka for pasting the link. And would it be correct to say that the report you update? Yes, when you connect automatically to direct query, it will automatically import. So when I teach Power BI classes, I encourage people to build a report only one time so that data will be automatically updated. Try to connect it to direct query. Minimize the amount of times you use import, unless you are using fixed data. But if the data you are using is data that is changing consistently, please try and ensure that you connect directly. Of course, the scenarios may vary, but yes, if it connects directly to data, it will automatically update. So let's assume that this Wale's data was live data and it connected to it directly. By tomorrow morning, the number of trips will have changed from 2151 million to something else. God bless you. Thank you for that beautiful question. All right. In the absence of any other thing, Samuel James.
There's a hand up. Okay.
Yes. Thank you, Samuel James. What's your question, please? Samuel James, we can hear you, but you are sounding very distant. you are very distant, but just talk. I'll try to strain my ears.
I want to say thank you so much, TS, for this. I want to find out for some of us who are really trying to, who are already migrating, for some of us who were like, have been in finance for the past 4 years. But I really want to do much more in analytics part of the finance and other data like business analytics. What's just that key thing I need to do?
Okay, I cannot hear you again, but what I think I heard is that you have been on this journey and you want to know how you can make progress or what you can do to grow. Send a mail to us at the email addresses that I shared in the chat, but I can also give a direct answer that one of the reasons why we launched Analytics Africa is that we know that in the midst of many programs, Utiva, Lentor, data science, Nigeria, in the midst of many programs, a lot of people are still kind of confused. So one of the things we are going to try and do is to launch some learning paths to say, hey, these are the courses that you should take if you want to become this kind of person. These are the courses that you should take if you want to become that kind of professional. And if this is where you want to go, these are the kind of things that you should do. So it's one of the things we are planning to do. We are launching a partnership in the next few months with a US-based nonprofit where they'll be giving us a free data literacy course and a couple of things around that line. I'm also talking to a company in India where they have a data science program, and I'm trying to talk to them to say, guys, bring this course to Africa and give it to us as less than half the price. So those are some of the things we are doing. And if it is a need for mentorship that you need, still send us a message either via the link posted or via the email that was dropped there, and we'll be able to come back. So just be on the lookout. We are working hard to give you all the necessary info that you need and all the necessary guidance. I didn't hear you perfectly, but I guess I have given a response to your question. If I did not, please send us a mail. Any other person, please? No other person. Okay. In the absence of any other questions, comments, and every other contribution, thank you, everyone. Thank you, Yinka. Thank you, Theophilos, for supporting us. Thank you, Wale, for your support and listening absentia. And for those who joined and dropped off, thank you. And for those who will watch this recording in future, thank you, everyone. Mary, I hope we share. You will get the materials within the next 1 week because some things need to be fine-tuned. They need to be converted to PDF, or we will definitely share the materials to you, with you, not to you, with you. Okay, Samuel James is happy. Thank you, everyone, and have a pleasant evening. I'm wishing you a happy new month in advance. All the best in the month of June and for the rest of the year. Good night, everybody.